As David said, my name is Benjamin Beer. Usually I have to add some kind of dad joke there and say that one of my ancestors was Irish, which is why we got the Beer surname. I work at AGCO Corporation. I'll tell you a little bit more about who we are and what we do here in a minute, but I'll give you a bit of background to this talk here. The title is deliberately a little clickbaity. This talk has been in progress in planning since about September last year, I believe, was when David and I first started talking about it. The goal with this conversation was to be less vendor specific, so I don't want to stand up here and tell you that Claude is better than Gemini. But I'm also not trying to be a general consultant trying to give you the iffy faffy. I'm going to actually talk about how we've built some AI and how we've done it in context of a very large corporate America company that is in the public finance space. So I'll start here with a little bit of an agenda for this evening. There's 4 big points. About a year ago, when I first started doing public speaking at AGCO, we had to go through media training. We're a public company, and you go through these things. And they told me that audiences love things of 3, so you need to put things in 3. And so naturally, I wrote an agenda that has things in 4. So first we'll start, I'll give you a little bit of context, and that's the heavy metal and high finance, who we are as AGCO and what I do there. Then I'll talk a little bit about the background to a problem and how we avoided quite a substantial trap, which is where you would engineer people problems. We'll get to the bulk of our conversation, which is going to look at the 99% discount. That number is not a clickbait number. That's a real statistic from a real system that we deployed, and we did really save 99%. So I hope to keep you around until then. And then the last topic here is one that David had requested. I'm going to talk a little bit about a chatbot and how to have it stop hallucinating in a financial context. Chatbots are fantastic tools. They're all over everywhere now. They've become a bit of a ubiquitous software tool, but they're very good at hallucinating finance numbers. So our first iteration that we built used to tell us that we will have a $3 trillion OPEX budget for 2024, which is both a year that has already passed and is more than our entire company's value. So we've learned a couple of tricks there. I'll start with heavy metal, high finance. This will be a quick section I'll go through. The machine that you see up there is a Fendt 1167 track tractor. It is a monstrosity. It is about, I would guess, it's 4 meters high. I don't know what that is in feet, but 4 meters high and 4 meters wide at its widest configuration, and it's built in southern Minnesota. This is one of the machines that AGCO Corporation builds, who I work for. We are the largest pure-play farm equipment manufacturer in the world. That means if you take our competitors and you remove construction or you remove any of the other industries that are not agriculture, we would beat them in the amount of things that we build. The machine you see behind there is one of our machines we build. I'll tell you a little bit more about it in a second. Here's some couple facts about our company. We have 24,000 employees, so we're a medium-sized company, I'd say. We have, as of 2024, roughly $11.7 billion of annual revenue, and we collect that revenue across 140 different countries. So we have a lot of people in a lot of different jurisdictions that are doing a lot of financial work for us. We also do quite a bit of work in the R&D space. We naturally, if you build giant machines, you've got to spend giant amounts of money to engineer them, and that's where we do a lot of them. Our brands here on the right, you might recognize some of them. We have Fendt, Massey Ferguson, and Valtra. These are our big machinery brands. And then our latest addition is PTX, which roughly 2 years ago went through the largest acquisition in agriculture history in the world. So we acquired, it was a big deal. A little bit about who am I? So why am I up here? My story starts with programming, as all good, astute engineers usually do. When I was in high school, I knew I liked programming, I just didn't know which. So I started with a double major in computer electronic engineering and kind of figured out that most of programming doesn't interest me, but a very small portion of it around decision support does. And I learned that by the first work that I did was for that vehicle there on the top left. That's a solar-powered car. If it weren't for COVID, we would have driven that thing, the hope was we would have driven that thing across the entirety of Australia. And the restriction that you have is you can have no energy except that which you generate on the machine. You're not even allowed to pre-charge the batteries on day one. So the first 4 hours of the event is nothing. You stand in the sun, and then you take off from there. And you're constantly doing evaluation and AI optimization, and you're trying to run some of these things in real time. And that's where I discovered this thing about data science and AI. I got to the US to do my master's in industrial engineering at Wichita State. That's my alma mater. That's how I ended up at Wichita, of all places. And I joined AGCO in 2023. Now, this machine you see here, this is I alluded to this a little earlier. This machine is called a Fendt Rogator machine. It was invented in the 1950s, also here in North America, and I got my work started doing my work in industry by building software for that machine. A couple quick facts, because I'm an engineer and a nerd and I love my numbers. When that machine is raised to its maximum height, the clearance between the lowest point on its chassis and the ground is 72 inches. And when it's unfolded, its boom width is 132 feet. So it is a substantial machine, lots of engineering. And I started working with these. They're built in a small town in southern Minnesota where our factory makes up most of the town. So I currently work as a senior data scientist at AGCO Corporation, and I work in the finance department in a team called Global Forecasting. So I have an unusual background. I went from machinery to working with accountants, but there is a reason for that. I now work as an engineer in accounting, which has its own story. The talk we have here this evening, I'm going to start with a little bit of background. My point in the conversation here is I don't want to give you a LinkedIn post. So I want to talk a little bit about some personal experience around how we actually built AI. There's a lot of AI that's out there, a lot of software. It's almost ubiquitous now, a lot of vendors selling all sorts of things. And this story that I'm going to tell you is not a story about how we went and bought software. It's a story about how we looked at a couple problems and we looked at AI and we shifted our mindset away from replacement technology. So instead of going in and saying we're going to go in, strip out a system and then bring in some new system from a new vendor, we said, well, our fundamental thesis is that AI is a great augmentation technology. That's how we're using it in our machinery. This machine is built here in Kansas, just out of interest. We use AI as an augmentation technology, so how can we look at that perspective by using it in our workforce and in our actual tooling that we build? And that's the whole, I would say, the central thesis of the conversation this evening. I'll start here with the background, which is the trap we avoided. In finance, when I started the team in finance, coming out of engineering, one of my first mandates was quite literally the most corporate mandate you can get. I was told by a senior VP, go do AI and make us quick. That was it. That was the context of the conversation. That was what I had to work with. And that spawned a lot of investigation. So that VP is a very good mentor, so I don't mean to denigrate him, but he has the saying where he says, when we work in finance, you're essentially just a detective that chases numbers. And that's exactly what I'm trying to show here. When we look at our company, across all the employees, across all the accounting that we do, we're really, really interested in certain numbers that go out. And sometimes that number can be as small as individual dollar amounts. When we do auditing, we want to know if someone's using a company credit card to buy Starbucks when they shouldn't be. For the first mandate to go and investigate and find numbers, what we're very interested in is the numbers that tell us a story and that help us make better decisions. So on the low end, it could be individual dollar amounts where we're trying to figure out who's using the company credit card for things they shouldn't be. But on the high end, it could be suppliers that are overcharging us, sometimes deliberately, and we're not catching it. Or it could be entire divisions that are running over budget in March for their full year budget that's going to end in the end of the year. Now, being able to find that in a global company where your data is everywhere is a very, very difficult problem. In terms of some numbers, if we're looking at this figure here, our numbers are around a couple 100,000 financial records that are being produced every month across the whole company in one system. So when you start aggregating them up, to be able to look at individual numbers, do outlier detection, and get better decision making, your data scale is millions of records that you're processing every month to try and build a picture, build a story. And because you're a public company, you have certain public finance restrictions, you have a very limited time window within which to do it before those numbers get locked. So the first question that we started looking at was, well, why is it so difficult to do this? Why is it so difficult to take a question such as, what is the OPEX for our Kansas facility? And why does that question take an analyst 6 days to build? Or 4 days, or whatever. And that's when we started looking at local reality versus global mandate. Our company, because we're spread all over the world, there's a lot of financial context that lives at each of our sites and each of our different places that is very important to the way that those processes take place. So naturally, big giant corporation, we have lots of information silos. But instead of saying information silo bad, let's kill them, we said, well, why are information silos there in the first place? The example that we saw a little earlier on is, I'll pick on Brazil specifically. Brazil has a very complicated payroll tax law. And when you study accounting in Brazil, you learn about that in their accounting school, but it's very different to anyone else, anywhere else in the world. So their ERP systems, their accounting systems, the way they build spreadsheets is very different to the rest of the world. And it absolutely infuriates our officers that are in Germany because they do accounting very, very differently. Naturally, the Germans do things very differently from anyone else, but you have a lot of this cultural context that comes into play there. So the trap to avoid is data centralization or data standardization. If I go back to this picture here, what has been the norm for many years, even at us, has been to say, all right, we can't standardize in one system, but let's all agree to use the same Excel template. Or let's all agree on the same PowerPoint. When you're dealing with cultures and languages at sites that you can't control, that have their own different context, to start mandating things like that, you start engineering people problems. And that's the real big trap we're falling in here. The standard practice that we learned and we were recommended by researching and figuring out and looking at consultants is one of three items. It's either warehousing or data lakes. Throw everything central. So if we look at this, I'm going to jump quite a bit between these two figures here, but if we look at this figure here, the best practice that we got recommended, particularly by a lot of cloud vendors, is, well, just throw everything in a data lake in one of those regions, and then you can use our platform to access that. That ain't going to work if you're running millions of records a month in finance with ragged hierarchies. The other approach is just go and buy some giant software platform. You have different languages, different cultures, so one software platform that makes sense in Europe doesn't make sense in South America. And then the last one is just throw it all in the cloud, which basically captures all of the bad advice in those first two. Now, right around the same time we were looking at this, there's a mentor of mine who actually gave me a pretty good quote, and I'll put it up here. His quote is, you cannot fix people problems with engineering, but you can engineer people problems. And this is important to think of in an AI world. There's a lot of AI that's telling us we're going to lose our jobs, we're going to be replaced, we're going to be made obsolete. But a lot of those, I think those quotes sometimes forget that we're people and we're in people processes, in cultures where people created the cultures with languages that people created and speak as well. And that's the context around this, but it's also the trap for our situation that we did not step in. But it took some work. We were close on our way there. We had a couple of vendors who promised the moon. So if that's the background, that's the trap, that's what is the problem. The next section that I'm going to talk, this is the bulk, is what's the unlock? What is that 99% discount? That is a real number. How did we get that? How do we do that? The first thing we did before we started building anything, when we realized, hang on a minute, vendors are pitching us all sorts of software. We have all these different contexts coming into play here. We have all this compliance stuff, all the legalities. You're talking through accounting, all this best practice from all over the world. What is the problem? Why is that a problem? And what is the nature of that problem? And the nature of that problem is really two things specifically. It's ragged hierarchies and local context. When you look at a lot of data information, there's a lot of great platforms that exist today, especially around BI, business intelligence. Those platforms are fantastic grid-like replacements that come in and promise to replace Excel, and in some cases they do, but they work with a very rigid structure. When you're dealing with financial records, I could have a cost center this month that no longer exists next month. So then my hierarchy breaks. And we tried this approach. We said, okay, well, let's try a BI approach. And that's where we realized you run a data engineering exercise because your data is shifting all the time. It's very hard to define where that data is shifting to. It's very hard to build a system that can expand around that. So it's almost an impossible problem to do that, or so we thought. The solution to this lies in shifting your mindset around how you build AI and how you build these tools. And that's where the true economics part comes in. And the description that I alluded to, it's this horizontal layering. So one of our big theses that we figured out very early on is that AI and data science, we actually figured this out before AI was a big thing, was particularly data science as a field in a company. As you start incorporating it in your workflows and in your processes and bringing people in that field, you can't silo AI. You can't silo data science. The best way to structure those departments is to think of them as horizontal departments. So where you have your traditional accounting as a vertical, legal as a vertical, compliance as a vertical, a data scientist that you go and place in each one of those verticals that reports across its own horizontal has a lot more power than having each of those verticals build out their own data science teams. And the reason we found that this is so powerful is because you can capture local context, but you also capture the people element. If I have an entire data science team that I remote offshore somewhere that never gets to the office, that never works in that team, that's where we see this proclivity to shift towards software, where we just come in, replace everything, blow over everyone. We don't really care about the process, and the result is that everyone becomes equally inefficient at the end. What we've learned with the horizontal approach is that you can actually scale this horizontal approach and roll it out very good, and you can leverage talent platforms where they exist. If you have a brilliant data scientist sitting at your head office in Duluth in our case, which is where we're headquartered, and you have a data scientist sitting in Kansas at the Heston site, there might not be enough work for them in one place to stay in one place and stay in that one vertical. Or they might not have the right boss to report to, or people that don't have the experience. But in a digital era, when you structure this as horizontal, you can capture that value and grow that value. The question then becomes centered around two things, and that's where this big slide comes in. The two things that we became very, very concerned about in the last couple of years as AGCO was innovation and competitiveness, natural competitiveness. In all the different vendor approaches and all the different software that we've looked at, competitiveness is something that is a lot of times understated, particularly in corporate America. If my sales department and my competitor's sales department and their competitor's sales department are all using the same vendor software, just with different contracts, our processes are the same. So the surface area for innovation is near zero between them because we're all doing the same thing. We're chasing the same leads through the same human processes because the natural proclivity for people is not to fight their work, it's to work with the work. So when you go and impose a software platform and say, thou shalt Salesforce, not to denigrate Salesforce, it's a good platform, but when you start imposing things like that, the learning that we had is, well, hang on a minute, people start losing their innovation and they do whatever that software platform says. So if that software platform says step 1, 2, 3, that's what the people processes become. And when you go and roll out that software platform, especially when you centralize that software platform, you say, all right, we're going to sign a contract with a vendor in North America, save some money and roll it out all over the world, you lose the people context, you lose the culture context, you lose the language context. The accountants are trained in Brazil with a context that we don't capture here. Now they have a piece of software that sucks. And that's where we have stuff like shadow AI and shadow software start coming in. So we took a very different approach when we looked at this problem. We had lots of conversations with our senior leadership, and we said, give us a shot. Let's take an approach. We're not going to buy any software. We're going to do all of this internally. We're going to give all of your accounting data in one platform without actually moving anything anywhere in a platform. And that's the approach that you see outlined here on the screen. So I took a long way to tell you the background story for a while this figure came up. I tried to go with less slides and more words. But what we learned is that if we take our data and we look at different systems, I have here 3 listed at the bottom. SAP is a very common ERP system. It's used, it's ubiquitous almost. We have Excel, which is the tool that no one can ever get rid of, and then various local databases. When you look at those software systems and you try and do data laking is trying to yearn towards this horizontal platform, and it doesn't always work. So we said, well, instead of us moving the data up, let's move the platform down. So we built a platform, which is this horizontal layer, using open source software, where we said, instead of us taking data laking and putting a data science team here in the middle and trying to figure out how to put these things, let's build our own platform. And from that one platform, we serve everyone. So we have tools for analysts, we have reporting for the executives, and we have tools for the data scientists and engineers who want to come in and build AI on top of the system. Now, we built all of this. I promise not to make this a super engineering talk, so I'll quickly gloss over this. All of this was built because of the productivity advances we could get out of AI. When we started the system, it was me working alone on trying to create the system. We looked at vendors who could come in and for 7 figures a year give us 80% of the solution, And that last 20% is kind of the promise that they had. We don't have it now. We'll have it in 2 years' time. We may or may not charge you for it. Then we looked at it and said, okay, well, if we build this ourselves, could we not go and find 80% somewhere else? And the answer is yes, you can. You can find open source software. It's not perfect. It does need a little bit of work. But if I can get open source software for free, or I can pay a vendor 7 figures a year for 80% and they both give me the same thing, because we're thinking of AI as an augmentation technology, it behooves us then to say, well, let's go and get 2 or 3 people at our company who can get good at that, use their data science skills, and actually build that platform. And that's what we did. Now, this sounds wonderful. I've spent a lot of time on this one slide. Show me the numbers. What did we actually learn out of this? Where does this 99% discount come from? I'll start here on the top left. That whole architecture diagram you see over there, from this diagram until we had the first prototype demo was 2 weeks with 1 developer working on it. We managed to do this in a global company because of AI tooling. So AI coding tools, you've heard about Claude, Gemini. We didn't vibe code the thing to start with. We said, well, let's take an open source code base. We'll use AI to train the people on the code base. And then we'll use AI to understand that code base, how we expand it. So within 2 weeks, we had our first prototype to build that last 20%, which is something our vendors couldn't deliver. Within 2 months, we had our first full user onboarded in the company. And within about 5 months, if I recall, we were servicing 120 different people all over the business using this software every day across 20 million records. Those records average sub-second query speed. So very quick data that we're accessing very quickly, and we're doing it without changing any of the underlying processes. We never once switched off a piece of software. We never once went in and said, stop using this, use this. We had 0 change management. This was me working remotely with AI that said, here's a new way to do things. And people naturally shifted over. Now, the last point here is the 99% discount. When we were done, when we delivered the first version, I would say in September is roughly when we went live with the first full version. We looked at the next best vendor that we were quoted, that they had a solution. That was the 80% solution, didn't have everything. Our total infrastructure cost to service 20 million records every month that we query in real time across engineers, analysts, and executives for that entire platform came out to be 0.3% what the next best vendor was capable of quoting us. So it wasn't just a slight cost savings, it was a rather substantial cost savings. But there's also this, I'll harken back to what I said earlier, you also had this cost of innovation and competitiveness also come in. For 0.3% of the cost of our competitor, we built a piece of software and tooling that no one has access to. It's ours. We leveraged open source so we can continue updating it with whatever the best practices that becomes available. Or we could give back if we wanted to. Haven't convinced them in the compliance department to let me do that yet, but it's work in progress. We can build all of this ourselves, and we can create facets for innovation. Because someone can come in now and say, you know what, Ben, this feature over here, I really don't like this feature. And we have the opportunity to say, great, you want to donate 2 hours of your time to help me change that? Or do you have an analyst in your team that can come in and code some of this? And that's exactly what we're using the platform now. When we realize we look at dashboards and we look at data views and we look at these things and they say, well, this data view doesn't make sense for me in South America. Our first question is not, well, let's go hire someone to do it. The question then becomes, okay, do you have an analyst that can do SQL in South America? Here you go, here's your tools. So when we go back to this horizontal picture here, each one of our people have exactly what they need to do in a way that's still entirely controlled. This platform here, the piece that I'm not showing here, is we have row-level data governance in here. So we have more data governance than what you could possibly ever want to have in an organization. If we wanted to, we could go in there and turn off all the things and turn off all the access control. So we can make compliance happy. We have all the things we need there. We can conform with privacy policies. But at the same time, I'm not going in and saying, thou shalt use only this platform. I'm just saying, well, here's an option. Here's tools, data. What you do with it is completely up to you. Stay within these guardrails. Have fun. Enjoy your life. And it's worked out pretty well for us. And that's where these statistics come here. So that is the bulk of the talk. That is the 99% discount for how we built that there. But as always, there's always a little bit more. Something David asked me to talk about was some of our experience around getting a little bit closer into the tech now around chatbots. I work in the finance department. We have lots of finance questions, and generative AI for us is a great game changer because the speed of access, the speed of accessing insights with it is where its greatest value is. Questions such as, what is the OPEX for an entire division? That's quite a complicated question. So with our data strategy that we built, with our own internal tool, we can deliver that. That maybe takes a week to build that out. But you can start answering those questions in perpetuity. But trivial questions such as, what was last year's full financials? That's a file that lives on someone's drive somewhere. At least our thesis was that that's what it was. But the idea is that information lives out there already. How do we get that information? Now, what we started doing when we started building out our first chatbot was we said, well, let's take best practice. Industry best practice is you build a chatbot, ingest your documents, train on top of them, and then go forward. And the lesson that we learned out of that is that AI loves to forecast because it is itself a forecasting model. And so we did have an executive one day ask the chatbot, why is it that our tractor sales are down in South America? And the chatbot very confidently replied with 80% confidence, it was a big exclamation, tractors are down because farmers in Italy are using bleach to treat olive plants. So whether or not that's true, we never investigated, we assumed it wasn't. But we learned very quickly that AI loves to forecast, and that answer was a perfectly acceptable answer by all the guardrails. It went through them because it's a perfectly acceptable answer. But business intelligence tells us that bleach and olives probably don't mix, and they have nothing to do with tractors in South America. So how did we fix that? Well, we actually fixed it by going backwards one step, a half a step. We said, we'll keep AI out of this. We'll put it somewhere else. If you take an AI model and you really zoom in into it with a microscope, all the way into it, all these large language models, Gemini, Claude, all of them, at their heart, their core, is a forecasting model. They're forecasting text, they're forecasting characters, or there's a lot of complicated terms that they put on top of it, but it's essentially just forecasting what comes next. That is a very, very good application for flows. You want to know what is the next step in a flow, but it's a very bad application for just tell me what I need to know, because it's already there. The AI's proclivity is to say, I'm going to invent a number based on what I've read. And so when you use the traditional approaches and you say, here is the net sales report from last year, it says, I have read this, I think $3 trillion. It's not completely right, but according to its own logic, it's not wrong. So the route that we solved this is we stuck with our AI as an augmenter approach, which is we used tooling instead. So here I mapped the question, what is the OPEX for Brazil? That goes into what we call it the Overlord. We use the Darth Vader logo as well. But we created a router or an orchestrator agent. And the purpose of that orchestrator agent is to predict the workflow. It's not to actually predict the values. So it takes the user question and it says, my prediction is, this question is a net sales question. Well, clearly, they're asking for OPEX or sorry, no, it's not a net sales question, it's an OPEX question. So it'll predict something. And then there's an agent that will work and take that prediction and say, okay, we've predicted that the answer for this question lies in the OPEX data. Where's the OPEX data? And that's where we hit the tool layer. So instead of the AI saying, I'm going to go into your database, look for it, and query, we created this wall, this brick wall. We called it the semantic layer. We didn't dub the name. Someone else had figured it out already. But the semantic layer, what it does is it allows us as data scientists to go in and code relationships. So if you think of a UML diagram or if you think of a database diagram, those big blocks with the relationship showing how everything fits together, what the data relationships are, turns out there's a way you can code that. And we can represent that coding and give that to an AI. So we take that coding, we put in that semantic layer, we hard code those tools and we say this data can only be put together with this data. This aggregation can only be run against that data. You code that out, and you expose that through tooling to an AI. The AI then says, instead of trying to predict the number, it's predicted which tool is most likely to use. And in our case, because you're doing it algorithmically, each type of number aggregation that you're putting together is itself a tool. So then it knows exactly, okay, that's the button that I need to press to get the answer to that question. When it presses that button, a coded routine that we can control, test, verify, and run deterministically goes and retrieves the data, comes back and replies. Now, I had a slide where I was going to put some of our accuracy statistics on here, but I had fear that it might look like rubbish because This approach yields a 0% hallucination for us. We have not had any hallucination, and it's been live for a couple months. What it does do, though, is it doesn't answer questions if it doesn't know which button to press. So if we have not told it about net sales, and someone asks a question about net sales, it'll reply back and say, I don't know. And that is a frustrating problem for our users who perceive that as this AI is wrong or it's broken. But technically, the metrics are just shifting elsewhere. So it's a little bit of a trade for this. I'd much rather have it not give me net sales than me tell the CFO $3 trillion very confidently for OPEX, or bleach on olives. So that was the one slide on that portion there around the chatbot. I'm going to try and wrap these two together, a little bit two different disparate things here. The general theme that I wanted to wrap this with is I chose this picture specifically. This is one of the biggest machines that we build. This is the Ideal 10T combine that Fendt builds. I believe it's about 2.5 stories high. It's 3 stories high when it's fully unfolded. So a giant piece of machine. But it's a combine harvester. But what that machine there has that's unique to it, that's unique to our company, is has no steering wheel. If you look very closely, you'll see there's no steering wheel. It is the only combine in the world that has a joystick. So we had engineers that figured out that this is a pain point for farmers. We innovated and invented something, and we created that there. And that is farmers buy that machine from us, harvest food, and we use that machine to feed the world. And that's part of our vision at AGCO. We build machines that feed the world. I would wager that most of us sitting here in this room in data science, we're looking at decision problems. So you're trying to support decision-making capabilities, improve decision-making capabilities. My job is largely focused around that. And a lot of those decision-making is in asking the right questions. And in asking the right questions, we get to the right points of innovation. And when we get to those right points of innovation, you're able to package that together and deliver that solution that someone can use to go and feed the world, in the case of this machine here. The wrap to all of that is, I think that is my thesis at least, and you're welcome to disagree with me. We're going to have a Q&A, so please do. My thesis is that that is the true economics of AI. It's not that it's going to come in and replace people's jobs. It's not that it's going to come in and hollow out an entire industry. Some of that may be true as an ancillary, because some of that industry might need disruption. But it's not really true in the context of AI being the augmenter that's going to help you drive that innovation. In our case, we're a giant corporation. We're not necessarily known for efficiency. Very big corporations in America aren't always known for efficiency. But we were able to deliver a 99% discount over any of our vendors by changing our focus around AI and shifting that and building that software internally and defying that convention. So that's the closing that I'll leave you with there is, go and feed the world with your data.